Thank you very much, everybody. My name is Kannan Keeranam. I'm actually part of a brand new company, almost 1 year old in generative AI, is probably older. Product and commercials is my focus. And today I'm here to talk about a very important problem, which is high emissions and how do you root cause why certain cars are having high emissions in certain conditions. And this problem is pretty thorny, and that is where our company's specialty comes in. So we are Articul8 AI. We are an autonomous enterprise generative AI platform where we focus on the core of the core business problems for our enterprise customers, right? We help them rapidly build enterprise-grade, enterprise-scale autonomous generative AI solutions that actually sits on their core of the core data and their business process, and we actually like to call that the system of record kind of application. Without a capability like this, the core of the core cannot actually have a step function improvement, and those are the sort of use cases and the companies that we actually work with. So we actually have a very firm belief in how this company was founded. The Articul8 AI embraced, of course, the public innovation that is actually going on all around us. A lot of innovative models come out. We actually were one of the first companies we were actually incubating inside Intel Corporation. So we were actually part of Intel, innovating with generative AI even before ChatGPT was launched. We actually had our own models, and we were actually working on the likes of Boston Consulting Group to actually solve some of their core of the core problems, which is basically their advisory pitch decks, right? How do we infuse generative AI in actually solving a very thorny problem for Boston Consulting Group? So from there, we accelerated on to very quickly solidifying our company's focus. And we actually firmly believe in taking the advancements in the generative AI and making it very relevant for a specific industry. So in this case, today I will deeper dive into an automotive use case, but the company and the platform is grounded on the fact that we actually focus on domain-specific models based on highly proprietary and very niche data for any of these industries that we work with, be it automotive, be it energy sector, be it telecommunications, banking and financials. We actually have models that are very specific to that particular industry, and that's what we focus on. And it's not enough to just have an industry-focused model. These models need to adapt to a specific company, right? So I used to work for Intel for 25 years, and at Intel, we used to have all kinds of acronyms and terminologies that a lot of people outside in will not actually understand. We call it TLAs. What the hell is a TLA? TLA is a 3-letter acronym. If you're not inside Intel, you won't even understand what a TLA is. Acronym for acronym kind of a company. So what we try to actually do is take the industry-leading models and adapt it for the company and their specific core functions, right? And that's what we believe will actually get to the final outcome that enterprises will actually appreciate and grow more and more of their core business onto that. Now, when you actually have embraced publicly available models, when you have Articul8's own models, when you have industry models that we actually very closely work with industry leaders, and when you have company-specific models, what ends up happening is a myriad of collections of hundreds and thousands of models that need to actually come and work together harmoniously, right? And that is where Articul8's generative AI platform comes into play, where we actually have the ultimate flexibility that we give to the customer. This entire platform sits inside the customer's security perimeter, inside their VPC if they're on the cloud. In the case of AWS, all AWS customers who is actually inside AWS, their own VPC, this entire platform sits inside the VPC of their own infrastructure within AWS, right? And then we also have multi-accelerator support, right? So we do believe that the silicon architecture is going to evolve for generative AI from where we are today in 5 years from now, right? So we want to make sure our platform is multi-architecture supported, where your silicon could evolve over a period of time. The platform still works without the customers needing to worry about what happens if I actually make a different choice from what I have today. Then this entire ModelMesh, which is our proprietary technology, what we do is we talked about the myriad of models, the number of models that would explode in an enterprise. If all those models need to be orchestrated at runtime for which task, which model is best suited, that's where the model mesh comes into play. We actually have a mixture of generative AI large language models. We actually have traditional probabilistic models in our bag, and we also actually have other kinds of deep learning and machine learning models that we could actually embrace in order to get to the final outcome, right? So these models are in different sizes as well, right? Like when we approach and work on domain-specific models that I was talking about in the previous slide, we can actually have domain-specific models that are very specific to certain tasks as well, right? So that they are relatively small, and you can actually invoke those models to actually get to the outcome, and then take that model's output and evaluate if that model is giving the right answer. And all that evaluation takes place behind the scenes during runtime so that you get the best outcome as a customer. And this entire product is exposed as an API or set of APIs that one could leverage and build applications on top of it. And again, this entire platform sits inside the security perimeter. At no point in time, the data or the queries that actually gets asked to these generative AI applications that one would build on top of our platform never ever leaves the security perimeter of the customer, right? So then we build this entire platform on AWS, right? So even though the platform is hosting infrastructure agnostic, we leverage AWS to the core, right? Like thanks to Yogi and his team from AWS, we have a very strong 360 partnership going on with AWS, where we make sure that our platform is price to performance optimal, right? We leverage more than 50 different services to make sure the platform completely works in a cohesive manner to get to the end output, right? And we also actually are a launch customer for HyperPod, where all our training jobs, because we end up training at least a model in every 2 weeks, we have so much usage of HyperPod that we actually see a lot of efficiencies around how HyperPod is leveraged in our platform as well. And Yogi, you want to add anything more about how our partnership and how we leverage the services?
Absolutely. So I think the couple things that I call out is what's exciting for us from an AWS standpoint is the fact that Articul8 solves business problems versus solving a technical problem. And the fact that they're able to train new models with something that we call as Sagemaker HyperPod. Love for you to go take a look, more at that. How it is able to very rapidly, basically, take new models and train them and get them aligned to a use case. And together, we are basically helping, working with customers and scaling them to go into production very, very rapidly. That's also a big value that we see in terms of what we are able to get with Articul8.
Yeah, typically our production, start to value realization in production is in weeks, maybe about 6 to 8 weeks. We are in production at scale, delivering value on customers' data and in their own environment as well. So that is something that is a huge value proposition that our customers really love. And this is the reference architecture. I'm not going to dwell deep into this reference architecture, but you can actually see we leverage, as I said, more than 50 different AWS services as building blocks. I talked about several different large language models and domain-specific models and deep learning models. All of them are actually managed in what we call as an LLM IQ, which is an evaluation framework that we have within our platform, right? We leverage HyperPod, as we mentioned, for the training jobs, and we make it easier for actually customers to focus on their use cases and developing applications on top of this platform, as opposed to doing all the undifferentiated heavy lifting that is involved behind the scenes. Because this is not easier as it looks in the slide. Delivering generative AI solutions for enterprise is easier said than done, right? At scale. Right? You could actually infer value from, 100 documents to 1,000 documents easily. But when you're talking about 100,000, 1 million documents, and combine that with some structured data along the way and ingest time series along the way, it's really difficult to actually do this at scale. And that's where this platform really helps us. So these are some of the use cases that we have actually come across in the automotive industry. As you can think of, like in the automotive industry, we started with a very small use case with one of the largest car manufacturers in Germany. And we actually thought, okay, let us actually identify why certain defects are happening in a car during the quality check, right? We started looking at those defects, and initially the use case was, let me figure out which department within the car manufacturer need to deal with this use case to actually go and fix it. Then we started delving deep into the insights that the platform was able to give. It resulted in adjacent use cases that were really core to their business and how they managed this whole thing. So the use case morphed into, these are zeroing in on certain set of supplier parts, and we need to go talk to the supplier. What is the contractual obligations that we have with the supplier, and how do we map it back to what happens in the actual operations, right? So you are now dealing with some structured data and equally contract, which is a unstructured text. So several different use cases I can actually go talk a long day, but today we are going to actually focus on root cause analysis, right? So we actually work with Demicon, who is a domain partner for us. They're in Germany, and their Ditex team is deeply involved in solving problems that are really, really thorny for car manufacturers, right? So if you look at it, about 16% of total carbon dioxide emissions in the EU is directly attributed to cars. And World Health Organization is not very happy about it, as you can imagine, right? And car manufacturers are very much responsible to address this thorny problem. Now, how do you figure out what exactly is going on in a car, why the emissions are so high, when you have 400 different variables that are all non-linear in nature that are contributing to the emission spike? It's not a trivial problem to solve. And that's where Demicon actually contacted us. Demicon is also an AWS partner. And then we started working with them on, okay, let's figure out what the solution could look like. And this whole discussion happened when I was in Germany, a month and a half ago. And then we have a solution that actually now works with AWS and Demicon. So what we did was, with Articul8's automated data perception capability, we actually were able to throw in the raw data, test cycles that they do in cars. Every test cycle is about 30 minutes, and about 400 different variables get logged. And that raw data was fed into the platform, and the platform was able to autonomously give a view on what could potentially be the relationships with each of these variables and which variables are clustered and related together when an incident like an emission happens, right? So that is one thing that came out of the box from our solution. And then when we actually looked at the root cause analysis capability itself, they also wanted natural language interaction in that, right? So while they can actually use our visualizations to go deeper into why certain variables are actually behaving certain way to cause the emissions, we also gave them a natural language interaction interface so that they are able to ask questions and then go deeper and deeper into why these problems are happening, right? The outcome, of course, the European Union regulators will soon be happy when this gets implemented at scale. The engine and car quality will increase, and the greenhouse gas emissions will decrease, and the engineers will be happy to do more and more RCA with a lot more ease. So with that said, I have a quick demo that I would like to show, and let's click to that. So this doesn't have audio. I'm the audio here for you. So what we did was actually we ingested all the raw data, which is all the emissions data, for 3 different cars. Car goes through a run of about 30 minutes, and it actually generates about 20,000 rows each, right? And then once you ingest the data, you're able to derive summaries of what is going on in the car, natural language summaries. Once you have the ingestion done, you're able to visualize and perceive the connectedness between each of these data elements, right? So as you can see here, there are cluster of topics and there are individual topics where you can click and zoom through what is going on in a much more user-friendly natural language manner and in this knowledge graph manner you can go dig into what is happening at each one of this. So in this case, it is showing a summary of a specific test and what was inferred out of the specific test. So that helps them iteratively figure out these various data points and how these are related. In this case, you can see the NOx emissions and carbon dioxide emissions were peaking at a certain scenario, right? So the summary of that is actually very clearly called out. So this one again is unstructured text, and what was ingested was a time series data, right? The fusion between unstructured text and time series data is what you see in action. So here, if you go under topics to drill down further, you could ask natural language questions, right? What are the main contributing factors, right? Why is NOx emission high in a certain test? What happened? So as you can imagine, you can actually start asking all those questions, and every response that you see here is actually grounded, right? It takes you to a specific citation of which document and what is the source of it, and you are able to drill down to it in a very high-level natural language manner, right? You will, of course, exhaust your options of asking natural language questions. So the geek in the test validation, vehicle validation engineer wants to dive into the raw data and then the visualizations around it. We wanted to support that as well. And that is why actually we gave them enough to ponder over here. And then we will seamlessly take them over to the Insights tab where they can actually go deeper dives. You can generate documents from this summary. So you can actually have a printable Word document or a PowerPoint presentation. Okay, so there you go. Once you're done with your natural language interaction, you can now go into this kind of analysis. Here you can see there are peaks and troughs of these emissions, right? You can select a specific area of where you see the emissions, and you can drill into the top 10 contributing factors. Out of the 400 odd non-linear relationship variables, you can drill into what are the emission signals that you're seeing at a specific second. So this is a 30-minute x-axis here. You can go up to the specific second and you can look at what are the contributing factors, right? Here it says, okay, there is contributing signals from the vehicle, right? Something is going on with the way the driver pedal position is, right? That is contributing to the issue. And there is a temperature issue, and there is a fuel tank issue, right? So this is something that the test validation, the vehicle validation engineer would love to deeper dive into once they exhaust their natural language interaction with the tool. So overall, Articul8 is very focused on delivering high-value, core of the core use cases to many different industry, and this is our automotive industry example. Thank you so much for listening to us.